This is OCR's paper 2. It's the foundation to your paper from November 2020, non-calculator. And if we have a look at the grade boundaries, you need 42 marks for a 4 and 53 marks for a grade 5. So in question 1, we've got just some negative number work to do. People always get confused by this. Just start at that first number. That's where you're starting. And if you're adding 6, you're literally moving 6 that way. So 1, 2, 3, 4, 5, 6. If you did -1, add on 6, you would finish at the number 5. Bit more difficult for this one, but we're still thinking along the number line. We're going to start at 7 this time. And if subtract 3 goes that way, then subtract -3 goes that way. So you're going to go 1, 2, 3, and the answer is 10. Part B says write down 2 prime numbers between 10 and 20. Well, you just need to know your prime numbers. They're numbers that will only divide exactly by themselves and 1. 11 is a prime number, 13 is a prime number, and 17 is a prime number. Any of those will answer that question. Question 2, write 350 centimetres in metres. Well, every 100 centimetres is 1 metre. So we've at least got 3 metres. And then the 50 centimetres is half of this. So you've got 3.5 or 3.5 metres. Part 2, write 1.52 litres in millilitres. Well, every 1 litre is 1,000 millilitres. So we've got at least 1,000, and then 0.52. If we think about timesing 1.52 by 1,000, there's times by 10, there's times by 100, and there's times by 1,000. So 1.52 litres is 1,520 millilitres. Part B says work out 5.7 centimetres added to 30 millimetres. Well, there are 10 millimetres in every centimetre. So I'm going to multiply that by 10. I've got 57 millimetres. I'm going to add on 30 millimetres. 57 and 30 is 80 millimetres. It does say give your answer in centimetres. 80 millimetres, just divide that by 10. You've got 8 centimetres. Question 3, we've got some fraction work. We're looking at 1/3 is 2 somethings. These are just equivalent fractions. We've doubled the top. So we're going to double the bottom, and 3 times 2 is 6. Just get rid of that so we can see what we're doing. Part 2, 1 and 1/7, and it wants it as just sevenths. So what we're going to do is 1 times 7 is 7, and then add on this 1 here. 1 times 7 is 7, add on 1 gives me 8. And because we started in sevenths, we're finishing in sevenths. Part B, work out 0.8 divided by 2. Well, if we start with 8 divided by 2, 8 divided by 2 is 4, 8 halved is 4. We can then convert this to 0.8 divided by 2. Because this got 10 times smaller than 8, then my answer is going to get 10 times smaller. So the answer is 0.4. Part 2 says what's 1.7 times 2. Well, again, I'm going to do 17 times 2. And I'll just use a column method for that. 2 times 7 is 14. 2 times 1 is 2. Add this on is 3. So if 17 times 2 is 34, then I'm going to do 1.7 times 2. And again, this got 10 times smaller. So my answer is going to get 10 times smaller. Question 4, it says write 0.16 as a fraction. Whenever you've got decimals to fractions, your fraction will always be out of 10, out of 100, or out of 1,000. And which one are we going to choose? Well, if we look after the decimal point, there is 2 digits, and that's how many zeros I'm looking for. If there's 2 digits after the decimal point, I want 2 zeros, and then I'm just going to put the 16. Final part of this question says, what's 7/20 as a decimal? Well, there's several ways to do that. I'm going to use equivalent fractions. 7/20, if we times that by 5, we get hundredths. So we'll times the top by 5, and 7 5s are 35. And if we look at this question, 16 hundredths was 0.16. So 35 hundredths is going to be 0.35. Question 5, we've got some shape work to do. So we just need to know about the shapes. We've got, what is the name for a triangle with 3 equal sides? So it looks like that. That is called an equilateral triangle. Part 2, a quadrilateral is a 4-sided shape, and it says 4 equal sides but no right angles. So it's not a square because that's got right angles. What it is what you might call a pushed over square. We've got 4 equal sides, so all these sides are the same, but no right angles, and that is called a rhombus. Part B, we've got a rectangle, and we're asked to draw the rectangle's 2 lines of symmetry. Well, lines of symmetry are mirror lines. This side would reflect exactly onto this side, so that's 1. And then we've got 1 going across the middle there. This top would reflect perfectly down onto this bottom. Part 2, we've got someone saying the rectangle has rotation symmetry, so that's about spinning around of order 2. And Maya says the rectangle is the only quadrilateral that has rotation symmetry of order 2. Is she correct? Well, no. They never correct these students when they say things. If I draw something like this, which is a parallelogram, imagine if you took that and span it around, rotated it, the minute that this corner spins around and lands here, the shape looks exactly the same. So it looks like it does at the start. We spin it around, and when that corner gets to there, it looks exactly the same again. And that's why you've got rotation symmetry of order 2. It looks the same in 2 separate places when we spin it in a full circle. And part C, we're just adding symbols to this diagram to show that AB, so this line, is parallel to DC, which is this line, and we show parallel lines by doing little arrows like that. So here we've got someone travelling from home to Stoke, and it says the distance from home to Stoke is 100 miles. So straight off we know the distance. She travels at an average speed of 50 miles per hour. So we've also got the speed. We've got something about stopping on the journey, and then we're looking at times. But I'm going to start by saying, well, if I've got distance and I've got speed, I can work out the time that it takes her. So if the distance is 100 miles and the speed is 50 miles per hour, we can use a formula triangle where speed, distance and time, and if we're looking for the time, that's going to be distance divided by speed. So I'm just going to write that down. Time is distance divided by speed, which is 100 divided by 50, and 100 divided by 50 is 10 divided by 5, which is 2. Because we've got miles and miles per hour, that will be 2 hours. Now I'm going to go back to the question and look at this stopping for 20 minutes and arriving in Stoke at 10 past 10. So what we've got to do is work backwards to when she left home. So if we're thinking about 10 past 10, if we remove that 20 minutes, so 10, 10, take 20 minutes, just removing the 10 minutes, then another 10 minutes before that, that would be 9:50. It takes 2 hours to travel the journey, so now I'm going to do 9:50, take away 2 hours, and that's 7:50, and it would be AM. Question 7, we've got a bar chart about number of goals scored by separate teams in November. And Blake says the bar chart shows United scored twice as many goals as City. Is Blake correct? Well, as I said, they're never generally correct, these students, but let's just double check. How many goals did City score? 10 goals for City. And how many goals for United? 12 goals for United. So we just want to say something like 12 is not twice as much or not double 10. Part B, give one way in which Nadia can improve her bar chart. Well, there's not much wrong with this bar chart. It's quite good. But all I can see here is we don't start at 0. So let's put that on there. And then part C, Kareem says, out of these 4 teams, United achieved the highest mean number of goals per game during November. What assumption has Kareem made? Well, mean is about goals scored divided by how many games they've played. So if they all play the same amount of games, then Kareem is correct, and that must be the assumption that Kareem's making. So the assumption is that they all played the same number of games. Question 8, we're looking at 3 times 3 times 3 times 3 as a single power of 3. Well, we've multiplied 3 by itself 4 times. So there's the answer there. Show the answer to 2 to the power of 6 times 4 to the minus 1 is a square number. Well, 2 to the power of 6 is 2 times 2 times 2 times 2, 6 times. This is not 2, 4, 6, 8, 10, 12. This is 4 times 2 again is 8, times 2 again is 16, times 2 again is 32, and times 2 again is 64. 4 to the negative 1, something you need to be aware of, is a quarter. When you're raising to negative 1, you put 1 over that. So what this is saying is, take 64 and multiply it by a quarter, which is just finding a quarter of 64. So that's what we need to do, a quarter of 64. Well, half of 64 is 32, and half of 32 is 16. There is your answer, and 16 is a square number. 4 times 4 is 16. Question 9. Write each of the following ratios in their simplest form. We're going to start with 12 to 15, and we're looking for a number we can divide both sides by, and then we can't divide any further. I think both of these are in the 3 times table. So let's divide both by 3. 12 divided by 3 is 4, and 15 divided by 3 is 5. That wouldn't simplify any further. 5 is a prime number, so there's nothing I can divide it by other than itself and 1. Part B, problem with this, we've got mixed units. So when you've got grams and kilograms, you need to sort this out first. So 1.8 kilograms, well, there's 1,000 grams in every kilogram. So I need to times by 1,000. So 1.8 times by 10 is 18, times by 100, and then times by 1,000. So 1.8 kilograms is 1,800 grams. So let's start with that ratio now. 600 grams to 1,800 grams. First thing we can do is swipe off both of these zeros. That's the same as dividing by 100. And I notice that 6 and 18 are both in the 6 times table. 6 divided by 6 is 1, and 18 divided by 6 is 3. So you've got 1 to 3 as your simplified ratio. Question 10, we've got some fraction and some indices to work with. So what we've got here is b to the 6. The fraction is a division, so divided by b squared. And if we do b to the 6 divided by b squared, we need to do 6 take away 2. That's b to the power of 4. We've still got that 5 there, so you've actually got 5b to the power of 4. And then part B says, what's x to the 4 cubed? Well, whenever you've got indices in brackets and then some outside, you need to do 4 times 3, which is 12. This is x to the power of 12. Question 11, we've got Theo investing £500 and a rate of interest is 6% per year, simple interest. So we'll come back to that bit in a second. It says work out the interest. Well, interest is just the extra money that's going to be added to this £500, and it's set at 6%. So we need to find 6% of the £500. Well, 10% is just this number divided by 10, which is 50. We can scale this down again and find 1%. And again, I'm just going to take this and divide it by 10. So 1% would be 5. The minute I've got 1%, I can work out 6%. If you've got 1% is 5, then 6% is 6 lots of this. 6 lots of 5 and 6 5s are 30. So the 6% interest in 1 year is £30. Part B says work out the value of his investment after 5 years. And this is where we look at the simple interest part. Simple interest just means every year he's going to get the same amount of interest. So for 5 years, he will just get 5 lots of £30, and 5 times 3 is 15. Whack that 0 on the end. He gets £150. So in question 12, we've got a jacket that's had its price reduced by 20%, and that brings the price down to £56. And what we want to know is the original price of the jacket. So what we've got here is a reverse percentage problem. We're looking for the original price of the jacket, and that is our 100%. That's what the jacket starts at that we don't know. We know that the jacket is reduced by 20%, so this is the 20% that we're removing. And when we remove that 20%, we're left with 80%. And 80% of the whole total is the £56 that we're told. So what we need to do is scale this back up to 100%. So if 80% is £56, we can maybe scale down to 40% just by halving these numbers. Half of 56, half of 50 is 25, half of 6 is 3, 25 add 3 is 28. I might halve these again to get 20%. Just halving and halving. Half of 28 is 14. Why would I find 20%? Well, this is now the 20% that I removed to start with. So to find my 100%, it's just going to be my 80% added to my 20%, which is 56 added to 14, and that comes to £70. Question 13. And here we've got a bag containing red, blue and yellow and white counters. We've got a table showing the probabilities that they are picked from a bag. Okay. What we need to know to start with is that all these probabilities will add up to 1. So that's the first bit of information we need. It says down here that there are twice as many yellow counters as white counters. So we've got 2 missing things and a bit of information there. So what I'm going to do first is take what we do have. We've got the red is 0.24. We've got the blue is 0.34. And I'm just going to add these together to see what happens. 4 add 4 is 8. 2 add 3 is 5. Decimal point 0.58 is what these two add up to. I said that all these probabilities need to add up to 1. So what I'm going to do is 1 take away the thing we just worked out, the 0.58. So I'll set that out as a column subtraction. 1 is 1.00 just to make sure I've got matching digits. We can't do 0.8 or 0.5, so I'm going to borrow from the 1 and place that there. Then I'm going to borrow from the 10, make that a 9 and place a 1 there. 10 take 8 is 2, 9 take 5 is 4, and 0 take 0 is 0, so 0.42. We know that these two here need to add to 0.42. It says there are twice as many yellow as white. So what I'm going to do is take this 0.42 and not divide it by 2. I'm going to divide it by 3. If there are twice as many yellow as white, then there needs to be something for white that I can then double to make yellow. So that would make 3 parts altogether. So let's do that. How many 3's in 0.42? 3's into 0 is 0. 3's into 4 is 1 remainder 1. And 3's into 12 is 4. Straight away, I know this 0.14 can go into my white box. And I just need to work out yellow. And it says there are twice as many yellow as white. So I just need to do 2 times 0.14. Well, 2 times 14 is 28. So that would be 0.28. And that's going to go there. Question 14. This question is just about knowing your types of graph. It says sketch the graph of x equals 3. Well, here's the x-axis. You might say 1, 2, 3, 4. Here is where x equals 3. So it will just be a straight line, straight up and down. Most people draw a line across because the x-axis goes across. We're looking for where 3 is on the x-axis for x equals 3. Part 2 says sketch the graph of y equals x squared plus 1. Y equals x squared is a curve like that. It's a symmetrical curve like this U shape. So that is y equals x squared. And if you want to do y equals x squared plus 1, what you need to do is move this graph up by 1. So I'm just going to remove that. We're going to draw the same curve. But what's happened is it's gone up, and rather than crossing at 0, 0, it crosses at 0, 1. So that there is y equals x squared plus 1. Part B, again, this is just about knowing your types of graph. We're looking for y equals 1 over x. And y equals 1 over x does have this curvy shape, so it's kind of right. The problem is it will never touch these axes. It kind of gets really, really close and then just carries on going straight. And same here, gets really, really close and carries on going straight up. So the first thing that's wrong with this sketch is the graph will never touch the X and Y axes. The second thing is missed, or the second thing is done wrong, is Y equals 1 over X is actually symmetrical in terms of it will repeat down this side. So you'll have this reflection. So he's missed this bit. Anything along the lines of is missed this part of the graph where X is negative. Question 15, we've got some algebra to work through. So let's have a look at this. We've got 4A's. Take 2A's, so 4A's take away 2A's, you've got 2A's left. Then we've got negative 2B's, add in 5B's, start at negative 2 and add on 5, you will finish at positive 3. So that's positive 3B's. Part B, some multiplying of a bracket to do, so we're going to do 4 times X. And then we're going to do 4 times 3. 4 times X is 4X. And 4 times 3 is 12. And it's positive 3. So positive 12. And part 2, we've got some double brackets to expand. There's several methods used to expand double brackets. I like to use a grid. So I'm going to put X plus 5 there. And then I'm going to put X minus 2 there, and we just need to work out these middle bits. This is a multiplication. X times X is X squared. X times 5 is 5X. Minus 2 times X is minus 2X. And minus 2 times positive 5 is negative 10, or minus 10. What we've got is X squared plus 5X minus 2X and minus 10. They're your 4 terms. These middle 2 terms always simplify. So we've got X squared plus 5X take 2X, start at 5 and take 2 is positive 3X, and then the minus 10. Question 16, we've got a square, so straight away I know that all 4 sides are the same. And it says by setting up and solving an equation, show that the perimeter is equal to the area. So I'll start with this part. I'm going to set up and solve an equation. Well, if we've got a square where sides are the same, and we've just got algebraic lengths, then I'm just going to say that 4x take 10 is the same as 11 take 2x. I've just said that these 2 sides are the same, and that's true because it's a square. That's setting up the equation. I'm now going to solve it. We've got x's on both sides. First thing to do is get rid of your smallest x's. So add 2 x's to both sides to get rid of those. 4x add 2x is 6x. The take 10 stays and the 11 stays. That's gone away. That's why I did that step. Next step is to add 10 to both sides. Get rid of this. And we're left with 6x equals 11 and 10 is 21. And then final step is to divide both sides by 6. And 21 divided by 6 is a decimal, which is, these will both divide by 3. So 21 divided by 3 is 7. And 6 divided by 3 is 2. And then 7 divided by 2 is 3.5. So we're going to go into a decimal there. It says, show that the perimeter is equal to the area. So I'm going to start with perimeter. I'm going to think about these 4 sides added together. Well, I can pick any of these algebraic expressions. I'm going to go for this one and figure out what this side length is. So that side is 11 take 2x, but I know that x is 3.5. So this becomes 11 take 2x's becomes 2 lots of 3.5. You get 11 take away 2 times 3.5. 2 times £3.50 is 7. And 11 take 7 is 4. I could have chosen this other side and put 3.5 into there, and I promise you I would have got 4 as well. 4 times 3.5 take 10 will be 4. So anyway, I know that this side length is 4. That means every side length is 4 because it's a square. And what we can do is now work out the perimeter, which is 4 add 4 add 4 add 4, 16. We can move on to the area. The area of a square is just base times height, so I'll just write that here. Area is going to be 4 times 4, which is also 16. And that's what the question is asking. Show that the perimeter is same as the area. Question 17, we've got some cards with numbers on them. Someone's taking a card, replacing it, taking a second card, and adding the numbers, and then keeping a record. And this is the table that she can create to show the results. And we can see that 2 add 2 is 4, 3 add 2 is 5. We just need to complete this table. So I'm going to do 5 added to 2, which is 7. 3 added to 3 is 6. And 2 added to 5, that is also 7. In part B, we're looking for the probability of an even number. So I need to find all the even numbers in this table. So I'll just quickly go through my even numbers, picking out the ones that are in the 2 times table effectively. They're all the numbers that are in the 2 times table, so let's just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And a probability is a fraction out of how many things altogether. Well, if you count these up, there's 1, 2, 3, 4, 5, lots of 5. It's going to be 13 out of 25. There are 25 possibilities altogether. Part 2 says, what is the probability of a multiple of 3 or 4? Well, this just means we're looking for numbers in the 3 or the 4 times table. So let's find those. I'll just put a little dot in those ones. 4 times table. 4 times table. I'll do 4 times table first. 4 times table there and there. Yep. So they're my 4 times table. If I just go back through and look for the multiples of 3 or the 3 times table, there's 1, there's 1, and there's 1. I've already counted this, so I'm not going to count it again. Let's just count up these dots now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, it's 13 out of 25. And we've got an absolute madness fraction question, but we're going to do it anyway. Someone's writing these things for us. Charlie drinks a third of a carton every day, and Jasmine drinks 2/5 of a carton every day. Any apple juice left over is used the following day, okay? And they do that for 10 days. I think what I'm going to do first is figure out how much juice they need for 10 days, or how many cartons. So if Charlie drinks a third and Jasmine drinks 2/5, if we add those together, we can figure out how much juice they drink between them each day. To add fractions, we need common denominators. So 3 times 5 is 15, and we're going to work in 15ths. I multiplied this 3 by 5, so I'm going to multiply the 1 by 5. I multiplied the 5 by 3, so I'm going to multiply the 2 by 3. And if we add those together, 5/15 and 6/15 is 11/15. We drink 11/15 of a carton every day for 10 days. So I'm going to multiply 11/15 by 10. And if you're multiplying a fraction by a whole number, you just multiply the top by the whole number. So 10 times 11 is 110. 15ths. So that's how much juice we drink over the 10 days. Now I'm going to change that to a mixed number so we can see exactly how many whole cartons they drink. So how many 15s into 110? Well, I'm just going to count up in 15s. 15, 30, 45, 60, 75, 90. That would be 105. So that's 1, 2, 3, 4, 5, 6, 7. And then there's 5 15ths. I got to 105 there. And I was aiming for 110. So that's why there's 5 15ths left over. So this is the number of cartons that they drink. Now obviously we can't buy 5 15ths of a carton, so that's going to be 8 cartons. We just need to figure out how much this is going to cost them. Well, if we have a look, the cost of a carton is 70p. So we need to do 8 multiplied by 0.7. Well, I'm going to do 7 times 8, which is 56. If we want to do 0.7 times 8, dividing by 10 in the calculation, so dividing by 10 in the answer, it will be £5.60. So question 19, we've got information about a clock that chimes every 20 minutes. We've also got a light that flashes every 8 minutes. We know that they flash together at 8 o'clock. And then we're asked how many times between 8:01 and 12:30 do they chime and flash together. And we must show us working. It is a bit of a monster this, but it's worth 5 marks, so worth doing. Let's look at the clock first. I'm just going to start writing down times from 8 o'clock. So we know 8 o'clock is when they first flash together. So be careful with this one. We're going to keep just counting up in 20 minutes. So 8:20, 8:40, 8:60, 60 minutes in an hour would be 9 o'clock. I'm going to keep adding on 20 minutes to these times. Then I'm going to stop at 12:20 because if I went to 12:40, that's after this time. So I'm not interested in that. Now I'm going to look at the light. And again, I'm just going to start listing times. Remember, we already know that they've flashed at 8 o'clock. So I'm not interested in this one because I'm actually starting at 8:01. So I'm just going to start adding on 8 minutes here. And at 8:56, I need to add on 8 minutes. So 4 minutes will take me to 9 o'clock. And then 4 minutes after that is the total 8 minutes. That will be 9:04. I'll just keep going. And what I'm going to do, I'm going to stop at 10 o'clock because this is a bit monstrous, isn't it? I have to list a load of times because I'm just adding on 8 minutes. So if I can stop at 10 o'clock and just figure out how many times they flash together here. So I'm just looking for matching times in both lists. Remember, I'm not interested in that one because I'm starting at 8:01, really. Let's just find some matching times. I think 8:40 is the first matching time. Then we've got 9:20. Then we've got 10 o'clock. And I'm not going to go any further with these times because I can see there's a little pattern. If we've got 8:40, then we miss a time and there's a repeat. Miss a time and a repeat, and that's going to continue. Miss a time, that will be a match. Miss a time, that will be a match. Miss a time, that will be a match. The pattern will repeat itself. So we've got 1, 2, 3, 4, 5, 6 times that they will chime and flash together. We've got 4 congruent triangles. That just means they're exactly the same. And we've got 2 coordinates. And what we're looking for is the coordinates of these 2 points here. So let's have a look at what we've got. We know that this point is across to 4 and up to 9. So if this point here is 9 high on my y-axis. If we move across to this point here, we're coming all the way across to 17 and up to 12. So this point is 12 high. And if we go from 9 high up to 12 high, then we know that this distance must be 3, the difference between 9 and 12. So what I'm going to do is mark 3 on anywhere where I see the bottom of one of these triangles. So that's 3 and that's 3. The triangle is 3 across at the bottom. What we also know is that B here is across to 17. So someone's come all the way across to 17 to plot point B. And what we don't know is this distance. But we do know that here we've come across to 4. So we're starting at 4 and we're moving across 3. That would take us to 7. Moving across another 3, that takes us to 10. So at this point here, we're across to 10. And from there to here, we're going across to 17. So actually this distance is 7. And I'm going to do the same thing I did with the 3. Put a 7 anywhere I've got the height of that triangle. What we're looking for now is the point C. Well, C, I'm going to start at 4 and move across 3, 3, 7 and 7. So this point here starts at 4, 5, 6, 7, 8, 9, 10, 17, add 7 would be across to 24. And I know it's in line with A, so it's only as high as A. So that's 24, 9. Part D, well, we can figure out how far across we come. If we come across to part A again, we're starting at 4 across. We're adding on 3, adding on 3. So I know 4, 5, 6, 7, 8, 9, 10. I'm across to 10. And I just need to figure out this height. Well, again, I'm going to use A to help me. A goes all the way up to 9. I'm going to scooch across. I know that this measurement is 7. And I started up at 9. So 7 take away 9. Sorry, 9 take away 7 would leave me at 2 high. So 21, we've got some simultaneous equations to solve. I'm just going to write these down again so I've got a bit of space to work with. We've got 2x plus 3y equals 10. And then we've got 3x plus 5y equals 17. There's lots of ways to go about attacking these, but in my opinion, the nicest way is to get these two numbers to match. So what I'm going to do is take this 2, in fact I'm going to take all of this equation and times it by the 3 underneath. So I'm going to times everything there by 3. 2x times 3 is 6x. 3y times 3 is 9y. And 10 times 3 is 30. I'm going to take this second equation and times everything by that 2 above it. So I'm going to take that equation and times everything by 2. And what you get is 3x times 2 is 6x. 5y times 2 is 10y. And 17 times 2, 2 10s are 20, 2 7s are 14. That would be 34. What we need to do now is a subtraction from these equations. What I'm going to do is just work upwards. The reason I'm working upwards is because I've got bigger numbers on the bottom. So I'm going to do a subtraction, but working upwards. 6x take 6x is gone. 10y take away 9y is 1y. And 34 take away 30 is 4. If you didn't like what I did there working upwards, just swap these equations around. Put the red one on top and the green one underneath. Anyway, we've found that y is 4. So that's the first part of the solution. What we're going to do now is go to any of these equations at the top, and I always go to the top one. And we're going to rewrite it as 2x plus, not 3y anymore, because we know that y is 4. So 3y's becomes 3 lots of 4. 3y's. Y is 4. And that still equals 10. Let's work this through. 2x's added to 3 4's are 12. That equals 10. Just got a nice linear equation to solve now. So take 12 from both sides. 2x equals 10 take 12 is negative 2. Be careful with that. And then divide both sides by 2. And you've got x equals negative 2 divided by 2 is negative 1. We've got a probability tree and we're just looking for the errors in this probability tree. So the first statement says the probability that it rains on Monday is 0.55. Monday rain 0.55, that's fine. I might just want to check these two branches and I can see that 0.55 added to 0.35 only comes to 0.9. So there's the first error. These branches need to add to 1. So I'm just going to write that down. Second statement, it says the probability it rains on Tuesday is 0.25. So we've got Tuesday rain and they've said 0.75. So they've got these branches mixed up. So I'll just write that down. And then third thing that's wrong with this diagram is we've not got these branches down here. We should have rain and no rain down here, following on from no rain on Monday. So I'll just put that down. And there's your 3 errors. So question 23, we've got quite a nasty question to finish with. We've got a sector, which is just part of a circle. And we know that the area of this sector is 8 centimetres squared. So somebody's worked out the area. What we're looking to do is work backwards to find the radius. Well, the area of a sector is like the area of a circle. So we're going to write pi times the radius squared. That's how you work out the area of a circle. But because we've only got part of a circle, we need to find a fraction or part of the full circle. And what we've got is 120 degrees out of 360, the full circle. So I'm going to write that. Pi r squared, pi times r squared is the full circle. We've got 120 out of 360 degrees. So that's what I'm going to write. We know this area is 8. So I can swap that out and say 8 equals 120 out of 360 times pi times r squared. And now we're trying to rearrange this or change this around so we can work out what r is. Because that's the question. What is the exact value of r? So first things first, I can simplify this fraction. If I divide both things by 10, I get 12 over 36. And 12 and 36 are both in the 12 times table. So divide by 12 gives me 1. Divide by 12 gives me 3. So that entire fraction is simplified to 1/3. So let's write that down again. 8 equals 1/3 times pi times the radius squared. Just changing this to 1/3. If I want to rearrange this, then what I can do is multiply both sides by 3. And what that will do is get rid of this and bring it up here as a multiplication. So I'm going to do 8 times 3, which is 24. The 1 will stay, but we'll have 1 times pi times r squared, which is just pi times r squared. So timesing by 3 got rid of this third on this side, but I needed to times by 3 on the left-hand side. On here, I've now got a pi that's annoying me because I want r on its own, remember? So I'm going to divide both sides by pi. And what you get is 24 divided by pi equals, the only thing that's left is r squared. And if we're trying to get r on its own, there's only one step to rearrange this left, and that's to square root both sides. And what you'll get is the square root of 24 over pi is r, the radius.